Hi. First, if you have any question, feel free to ask. No need to wait. I gave the first version of this talk in 2013. And it was quite a change in my Rails career, because after that, I got a lot of contracts for training, consulting, for optimization of Rails and later Phoenix applications. And my main aspect is always to increase performance many times through cache. Today, I use two different sets of slides. The old ones from 2013 are with a black background, and the new ones are with a white background. The old slides use code examples. The new ones use agent prompts. I think it's easier for everybody to just copy and paste them and to redo that work in your own application. In German, we have one idiom which says, Kleinvieh macht auch Mist. And I thought this is a good way of teaching a little bit of German. So Kleinvieh macht auch Mist means that even small farm animals, which is Kleinvieh, make a lot of, and I know, and I didn't think that through. I don't know if I'm allowed to say what mist is in English. If that's PC or not, I don't know. Look it up. It's a real idiom. I use it every week. So stuff I didn't think about in 2013. Mainly, I didn't think about CPU cache. And that's, from today's perspective, in my opinion, the biggest, I don't want to say hidden secret, but too few people think about this. I asked ChatGPT to draw this pyramid, and you see ChatGPT has some problems with like here and there and whatever, but still I wouldn't be able to draw this myself, so I take it. CPU has internal cache, normally 3 levels, L1, L2, L3. A couple of them have a 4th level, L4. So before a CPU takes anything from RAM, it tries to get data from the internal cache. The L1 cache is directly built in the CPU, the L2 cache mostly times 2. And the bigger the number, the bigger the cache. So L1 cache is very small and L3 cache is kind of big. And you see how farther away, the more CPU cycles it takes to read that cache. So here L1 cache, that's just up to 5 cycles. And if you go down all the way to RAM, that's 100 to 500 cycles, CPU cycles. That is what is most important for me to understand, okay, how long does it take to get that data from that place? And you see hard drive or SSD, that takes forever in CPU cycle terms. Why is this important? I have these two minimal one-liner. One is 1 + 1, and one is getting the initials of the string Stefan Wintermeyer. This is the assembler code for this. So you see, it takes 5 CPU cycles to add 1 + 1, or any of this addition. So it would be stupid to have the result of this addition somewhere in the cache, because we can do this faster in the CPU. No need to waste real estate in the cache. This is an assembler code for the SW initial example. That takes 12 CPU cycles. So that's not fast enough for L1, but we are already in L2 land. So depending on your application and your situation, I wouldn't even bother about caching that either, because it's so easy and so cheap to calculate in the CPU. Why should we cache it? So for me, one of the most important things in the daily consulting business, there's no one-size-fits-all in the caching aspect, because it all depends on how fast is your CPU, how fast is the cache, how fast is the RAM, how fast is the SSD. There's a whole variety. So the very same code can do well on one machine and not so well on the other. So you really want to either understand your hardware or just try it. Write yourself a reg task with some benchmarking and test out what your idea is and then see what happens. Again, one size doesn't fit all in this aspect. So back to the 2013 slides, my setup in 2013 was a Raspberry Pi first generation. I used that because I wanted to show how little CPU power you need, or how little hardware power you need to run a nice web shop. This was the old model. We have a product, we have ratings, we have user, we have a shopping cart situation, we have categories, and we had discount groups. This was the old web shop. I think that was Bootstrap, and so pretty much normal web shop. And this was the slide I used to show how much improvement we got from the speed. So we started with this vanilla, that was our baseline, and here was the latest improvement from the caching. And I set up the same thing for today's example. So in 2025, we use a slightly better Raspberry Pi, the Model 3, because I'm cheap. Actually, I have this one here. Does anybody have a kid who wants to play with this? Okay, come here. It has a German adapter, so you have to get a US power plug. But say hi, have fun. Welcome. Anybody could have had it. So this is a new ERD, or the new models. It's pretty much the same. The only difference I did is I don't use discount groups anymore. For the same idea of changing data, I use expiration date now. So all the products have an expiration date, and I have a little bit more detail about the product, but that's it. So let's start a new Rails app and fire up Cloud Code and tell it what we want. We want an e-commerce platform, and here are the models we want. And I tell you, the last couple of months, bootstrapping a new application became much, much faster. So once we have the new web shop covered, I ask Claude to install FakerGem and to set up seed data for 50,000 products and some 200 categories, ratings for the products, and expiration dates for the products. So this is the result. We have a typical web shop. We have a shopping cart here in the top. We have, this is a show view. We can delete and we can add to the cart. Pretty normal basic stuff. So that is our base system. To measure any kind of improvements, we need some sort of baseline, and we have to measure it. So again, I fire up Claude and ask it to create a task where it uses the setup I'm thinking is optimal for this case. And that's different for any customer, for any web page. So I'm assuming that most users of this web page are just window shopping. And I'm guessing that's about 80%. So They are just walking through the web page, don't buy anything. And about 20% are using the shopping cart. So that's my ratio. And all the numbers will change if you change that ratio. That's very important to understand. So if you do that, you want to have a look in your Google Analytics or any other sort of analytics system and get a feeling of real user who use a shopping cart and just window shoppers. So as a result of that benchmark, I get these numbers. And I used to dive into views and DB and optimize it, and I still optimize it, of course. But as I said, it became a little bit more complex today because sometimes it is that I save, let's say, 1,000 milliseconds here, but for whatever strange reason, this one gains 2,000 milliseconds. That happens all the time. So today, I'm just taking the total time, and that is my benchmark, that is my baseline. So we start with about 30,000 milliseconds for this specific benchmark. The first thing I'd like to introduce to the code is select. The beauty of Active Record is you don't have to think a lot about this stuff. You just load everything, and everything is there by magic. The problem with that is, for example, for the category has a description. We don't need that description. But if that's a text, so if we load that description, we load our whole cache, we have a lot of information in the system which we never use. So the first thing here is that I tell Claude to please read the documentation for select, and then to use it to optimize our models and or the queries. And a good example here is created at. I don't use created at all in this application. So this is a result, quite a bit of optimization here. Let's dive into one. And this used to be include category, which just included everything from the category, including the description, which we don't need. And then it was replaced to select ID and name, because that's what we really need. And that saves a lot of space. The next step is optimizing the data types. Same idea. For example, the rating by default is an integer. The rating is 0 to 5 stars. I don't need an integer for that. A small int or a tiny int is good enough for that. And that saves space. So let's ask Claude to go through all the models and optimize the data types and use, for example, a small int if it makes sense. So this is the result. And you can see the ratings now is a tiny int, and we save 75% of storage. The state, same thing here, 90% of storage saved. Line items quantity, small int, 50%. This doesn't sound like a lot because we are talking about maybe kilobytes or maybe megabytes. I don't know. It's not like gigabytes. But this is not a lot either. So if we find a way to squeeze in all this information in the best case scenario in our L1 cache or L2, that means a big, massive improvement of speed. So you really want to, or no, who am I to tell you what you want? But if you really want to go down the road of maximum performance, you want to have a look at the select thing. You want to have a look at your data types because that squeezes out quite a bit. And that's, in this case, -3%. So the application just became 3% faster. Again, Client fee macht auch Mist. Indexes, that's a classic. I really don't have to talk that much about that. I asked Claude to analyze everything and to improve or to create indexes. So that's another 6%. And that didn't even take, I don't know, 10 minutes. So the application is already more than 10% faster. One project about index. which I see all the time. If you have two indexes, one is for last name and first name, and one is just for last name, and you need both, get rid of the first one. Because you can use the second one for this scenario, because it's from left to right. So you can use the second index just to search for last name. And that saves, again, space. Fragment caching, and that includes Russian doll, and that's a classic. So this is our application. And let's see what we can do with fragment caching. So these cards are fragments. We use the updated add attribute of each product as a key for that fragment. And Russian doll is easy. That's just once around everything. And you can stack that. So you can have, I don't know, multiple Russian dolls on one page. It kind of gets confusing after a time. It is a bit error prone. So you really want to know what you're doing, and it is hard to debug. And you need a clean data structure. But then it's magic. So again, I tell Claude to read the official guide for fragment and Russian doll caching, and then implement it. And very important, I tell it to include the updated add, because we didn't in the step before, but we need it now. And what is very important, every time we have something like a belongs to association, we want to touch the parent. To give you an example, if I change the rating, or if I add or delete a rating, I want to touch the product. Touch means updated add to the current timestamp. So that is very important. That's 60% improvement speed. So that's a big one. HTTP caching. HTTP caching means we still use the code in the controller, but depending on the situation, we don't render the HTML. And normally that's the part where we really spend time. So normally the controller is the fastest part. So we save time and money on the server, and we have less payload to deliver to the client. So that will be faster too. Normally we use an e-tag for that. E-tag is like a fingerprint. So if we do this, if I pull with curl 2 times the same page, I get 2 different e-tags. This means the page has changed. It's not the same page. So I'm asking Claude now to read the documentation and to implement a strong e-tag. What is a strong e-tag compared to a weak e-tag? A weak e-tag is something like if you have a proxy on your way from the server to the client, and the proxy thinks, okay, yeah, you compress this, but for example with, I don't know, gzip, but I prefer Protly, then the proxy can change the compression, but that would break the hard e-tag because it's not the same file. The weak e-tag would be the same. So weak e-tag means more or less the same. Hard e-tag means exactly the same. And this is a code which gets added to the controller, just 1 line for each occasion. And we use the top products here, and we use the product here. And this is a very good example of Claude failing, because we don't need the product ratings. Because we asked Claude to add a touch, then we don't need the ratings here. Yeah, go ahead. Come again? Okay, the question is, what does e-tag cache? The e-tag doesn't cache anything. The e-tag is just a fingerprint of saying, okay, before this is a controller. We don't see the beginning of that controller part, but let's say this is like an index view of products. So this e-tag just says all the products. It has a list of an array of attributes of the product list, and then it looks up what e-tag makes sense for that, And if nothing has changed, it's the same fingerprint. And otherwise, if one product changed, the fingerprint changes too. It's not a cache, it's just a fingerprint. And I'll show you why, or show what we do with that. So if we get the same page twice, we have the same fingerprint here, and that means the same page. And what the browser now does is the browser says, okay, I already have a copy of this, and that is this fingerprint here. That's e-tag. So has anything changed? And that's often like you browse through a shop and you go back and forth. So you already have that page. And if it hasn't changed, you don't need to render the HTML, because that's a waste of time. And in that case, the Rails system or the server says nothing has been modified, and that's in HTTP code 304. Did I answer the question? Okay. Any questions or another question? Yeah. Okay, the question is there a specific reason why I'm using a strong e-tag? The answer is yes, I'm German. So last modified, same idea, but now we are using a timestamp. So the code is here, the last modified, and we use a timestamp. So the request will look up, like the browser will say, I have a copy, and this is from this time in the past. Is it still good? And then again, we get a 3 or 4 if it hasn't been modified. So both work in parallel. I suggest to use both. There's no harm. So we save another 23%. That's already a big improvement. And that even for a big application doesn't even take a day today. It used to take a lot longer, but with Claude or other agents, it's very easy to do as long as you have a good testing environment. Testing with caching is absolutely key, because otherwise you always get in a situation where you have a situation where at development something works, but your customers are calling support that it doesn't. And it's very hard to debug. So the last slides are for what I call Autoban. I love German today. The fastest page that is delivered from our online shop is delivered by Nginx or Apache only, where Rails doesn't do anything. And this already happens. This happens always with these pages, like 404 HTML. These are static pages which are in the public directory and don't even trigger anything in Rails. So static copies of product show, and remember we have 50,000 products. Why not? So we tell Claude to create a method to store a static copy of that view in the file system in the directory structure. And while we're at it, we create a property compression version. So that's the state-of-the-art compression the browser uses. That used to be gzip, and today is Protly. And we just add these hooks in the model, which are triggered every time. And because I or Claude made a mistake, the delete has to be done here in addition. I guess it was Claude. So this is the result. We have a list of 50,000 files, and disk space is cheap. I don't care about disk space. And because while we are at it, we can use the protein compression too, because that saves time for Nginx. Otherwise, Nginx would grab that file, compress it, and then deliver the compressed file. And now Nginx says, oh, wonderful. There's already a protein version of that. Let's take that. So that's a big performance boost on heavy traffic sites. So how does Nginx know which one to use? Because now we have two different words. That's what cookies are for. So we ask Claude to set up the system where we set a cookie when somebody is logged in or when somebody has an active cart, shopping cart. If somebody logs out or has 0 items in the shopping cart, we delete that cookie. And this is the code for that. And this is the code for the Nginx. That's the config for the Nginx. And that's pretty much it. So that is a big performance boost. What we do have to do now is we have to create a cron job which runs every 50,000 products once a day at 0, 0, because we have that expiration date. So at the beginning of the new day, we want to delete all the files and recreate them. That is very important, because otherwise we get yesterday news. So now with this, we have a major additional performance boost. So we started at 30,000 milliseconds, and now we have about 3,500. So let's say we are down to 10%. And that means on the same hardware, we can have 10 times the amount of traffic, and everything is going to be faster. Why is speed so important? That's because we are humans. Every time you press on the button in an elevator or at a traffic light and it takes forever, you're in this table. Because if something takes longer than a second, the human does context switching. So the gold standard is we want to have web pages which load initially under 1 second, and everything after that should be even faster. Most web pages don't do that, but that's the gold standard. And if you really, the next couple of days, really whenever you have a slow web page, remember my words, remember this talk. You feel the sluggishness, and that's a negative thing. This is a slide from 10 years, 12 years ago. Nothing has changed there. Every second the web page is slower, increases the bounce rate by 0.65. And that's massive. So the slower the web page, the less products you're going to sell. That's the major reason why I'm stressing this point. So let's compare to random web pages, which I came up today, like 3 hours ago. This is Wi-Fi of the hotel. So I pinged RailsConf.org and I pinged my own web page. And you see the difference is quite impressive. That's because my server is located in Germany and RailsConf isn't. So that Atlantic makes quite a difference. That's 10 times as slow. So this is a web page we all use today. And this web page cries for caching. Like we see like all this fragment caching here, all these possibilities. That's just a perfect example of how to do good caching if it would be good. So let's have a look. That page, and if you want to have a look, here is a URL. I already uploaded the slides. I will publish the URL of the slides on my Twitter account at Wintermeyer. So this page, the browser starts to get the first byte at 0.3 seconds. So that's pretty quick. But then it takes more than a second to start to render. And render is just the browser does anything. And then it takes a little bit over 3 seconds to show you the page. So that's not below 1 second. And you feel that. That's my web page. That's below 1 second. And that's both numbers compared. And the tricky part here is, you see the first line. The first byte is way faster here than here. And that is because the Atlantic. I can fix a lot of things. I can make my server faster. I can write better code, but I cannot increase the speed of light. So everything has to move via fiber from Frankfurt to Philadelphia. And that's my biggest disadvantage here. I cannot fix that. But still, because everything else is fast, I get the web page below 1 second. And that's the gold standard. These numbers, by the way, are via LTE network, so that's kind of on your mobile phone. It'll be faster a little bit on fiber, but that's a good comparison. So that's for today. Everything for today. Any questions? No. Okay. One question. It's not the system. Okay, the question is, I said, did I? I said that Russian door caching and fragment caching is buggy, which I deny. I never said that. What I meant is, it's very easy to implement bugs in that. So it is very easy to get started, and then you forget about it. And then often you don't use caching in development, and everything is wonderful. And then on production, something happens. You forgot to, I don't know, you forgot to touch something. So, for example, you didn't touch the product with a new rating. And then the whole cache is, like, until the next morning, is corrupt. And that is very hard to debug. So that's the reason for that. So I made the Rails code is perfect. I have never seen any bug in Rails, never. Any other questions? Okay, the question is, have I ever measured SSD? Because today SSD became quite fast, yes. Like the first talk I gave in 2013, at those days, a lot of my servers used hard drive. So that was like Stone Age. My kids don't even know what that is. That was so much slower. So today is like, for me, it's like magic. But still, you want to have the fastest SSD possible, and it's that pyramid. So it is very easy to buy a cheap SSD, which is slow. And then that's wasting money. So you really, and yeah. Is that the answer to your question? Perfect. Any other questions? No? So remember, Client-Fee macht auch Mist. Thank you.